Hello, very good afternoon, guys. Welcome to BYJU'S exam prep. Very good afternoon, all of you. I hope everyone is good, fine. Good afternoon, guys. Good afternoon. All right. So in this session, we'll be practicing some 90s of the questions from the year 90s, 91 to 99. What are the different questions being asked from the your uh, engineering mechanics? We're definitely gonna discuss those important questions. So please do let me know whether my audio and video all good, all perfect, so that we can start off this very beautiful session on the Go Old is Gold questions PYQ from 1990s, 91. Basically, I've taken from 92 to 99 the some very important questions, and also kept in mind that because some syllabus is also being changed the last 5 6 years, so we have taken that point into consideration. Okay, so very good afternoon, guys. Good afternoon. Please do let me know whether my audio and video all good. Let me check my end also. All good, all set. Perfect. Perfect. All right. So, engine mechanics, I would say the most scoring subject, easy subject, purely conceptual, no theoretical aspect, only pure concept and application part is there. Right? There is no point to remember anything. There is only pure concept that you need to understand and apply those concepts, which you have already studied in your JEE preparations also. Right? Okay, so let's begin with the session, and we'll be taking some good number of questions and also variety of problem that was asked in 90s, and you will surprised to know that the some questions is being repeated in the recent PSU examination. That's the best part of this 90s PYQ. Okay, fine. I've taken some conventional questions also, so that your practice is being maintained for this GATE 2024. Okay, all right. So let's begin with the session, and I think all good with this audio and video. Let me check from my end also. 1 second, guys. Yes, very good afternoon. Good afternoon, all of you. Good afternoon. 1 second. Hello, Bunny. Hello. All good. Okay. So कैसी चल रही है प्रिपरेशन, तैयारी कैसे चल रही है? अभी तो बार का आने वाला है ना, तो बार की तैयारी कैसे चल रही है? बढ़िया। हेलो विकी, हेलो। देखो यार, जितना ज़्यादा प्रैक्टिस करोगे उतना ही ज़्यादा आपके लिए बेनिफिशियल होगा एग्जाम, कोई भी एग्जाम को क्रैक करने के लिए, क्योंकि एग्जाम में आपका कंसेप्ट देखा जाता है, क्या आप कंसेप्चुअल क्लैरिटी देखा जाता है, और डेफिनेटली आपको ये बहुत ही इंपॉर्टेंट है आइडेंटिफाई करना है कि कंसेप्ट क्लैरिटी है कि नहीं। अभी भी बहुत अच्छा खासा टाइम है गेट एग्जामिनेशन के लिए। उससे पहले यू विल बी हैविंग बार, यू विल बी हैविंग एचपीसीएल, यू विल बी हैविंग डिफरेंट एग्जामिनेशन, इवन इसरो भी अभी पेंडिंग है, तो डेफिनेटली बहुत सारे लाइंड अप एग्जामिनेशन हैं। यू नीड टू बी कंसिस्टेंट, ट्रैक से नहीं भटकना, ट्रैक पे रहिए, डेफिनेटली विल बी एबल टू क्रैक ऑल द एग्जामिनेशन। हमें तो एक एग्जाम क्रैक करना है ना, तो डेफिनेटली विल बी एबल टू क्रैक वेरी इजी। ऑलराइट, सो लेट्स बिगिन द सेशन। और इस सेशन का जो पीडीएफ है मैं आपको इस टेलीग्राम चैनल में सेंड कर दूंगा, दैट इज मैकेनिकल बाय सूरज गोपी, राइट। और कोई डाउट और डिफिकल्टी रहता है तो आप मेरे को बेहिचक यू कैन कॉन्टैक्ट मी ऑन दिस टेलीग्राम चैनल। हाँ, ये आई डू एग्री विद दैट। थोड़ा सा 19 तक आपका ऐसा रहेगा, है ना, संडे तक यू विल बी हैविंग स्लाइट बिजी शेड्यूल, उसके बाद आई थिंक यू विल बी बैक ऑन ट्रैक। क्योंकि देखो फेस्टिव सीजन में आई डू एग्री, प्रिपरेशन आप जब बैठते हैं करते हैं, कोई ना कोई आ जाता है घर पे, कोई ना कोई आपसे बात करने आ जाता है या किसी का फोन आ जाता है, एंड आई डू एग्री फेस्टिव सीजन में इट्स स्लाइटली डिफिकल्ट टू मेंटेन दैट कंसिस्टेंसी। इसीलिए आप एक काम कर सकते हैं, थोड़ा सा अपना टाइम, जैसे लेट नाइट यू कैन स्टडी और अर्ली मॉर्निंग यू कैन स्टडी, एंड इन बिटवीन वन एवर यू आर गेटिंग टाइम जस्ट हैव अ क्विक गो थ्रू, राइट। चलिए, इफ आई टॉक अबाउट दिस मॉक टेस्ट, आई होप सो सभी को पता ही है ना, सबने रजिस्टर कर ही रखा है, और जिसने नहीं किया है प्लीज डू रजिस्टर योरसेल्फ फॉर दिस फ्री मॉक टेस्ट शेड्यूल। ऑलरेडी वी कैन से थर्ड subject wise mock test schedule is already being will be over by tomorrow. तो जिन्होंने अभी तक अटेम्प्ट नहीं किया, यू डू अटेम्प्ट दिस वन. उसके बाद फोर्थ मॉक टेस्ट आएगा, सब्जेक्ट ऑफ मॉक टेस्ट. देन फ्रॉम in December, mid of December, you will be having the full length mock test. So that is sufficient enough to access to this. और फ्री ऐप क्लास में if I tell you, आज हम शाम को 5 बजे मिलेंगे ऐप क्लास. Actually the timing was 12 PM, but I've changed that into 5, not 5, 4 PM. ठीक है. But tomorrow onwards we'll be regularly meeting at 12 PM on our app classes. और ऐप में we'll be talking about HPCL और इंजीनियरिंग सर्विस के क्वेश्चंस लेवल हम लोग डिस्कस करेंगे और गेट 1 मार्क्स प्रॉब्लम. राइट, पीएसयू को टारगेट करेंगे अभी, एंड विल बी प्रैक्टिसिंग सब्जेक्ट वाइज प्रैक्टिस क्वेश्चंस फ्रॉम द different examination perspective. Right, so you can download the app from this link that you are seeing on the screen in front of the name. चलो, so let's go with the first question on the screen. बहुत easy question थे. When I've seen the 19th paper, क्वेश्चन का कुछ क्वेश्चन तो इतने इजी थे that I was thinking that not to discuss those easy question. वेक्टर एडिशंस पे थे, the resultant calculations पे थे. So I thought this type of question you can easily solve. So I've taken up some unique question which is being not being asked recently. So definitely you can expect these type of questions being repeated. चलिए, हाँ हाँ, आज है 4 बजे, 4-5 बजे का मैं कंफर्म कर लूंगा, है ना. वैसे तो 12 बजे का टाइम स्लॉट है एवरी डे फ्रॉम टुमारो ऑनवर्ड्स एक्सेप्ट संडे, है ना. सैटरडे, मंडे टू सैटरडे चलेगा 12 बजे. सो यू कैन डू ज्वाइन द ऐप क्लासेस. Okay, so first question on the screen. A stone of mass m at the end of the string of length L is whirled in a vertical circle at constant speed. मतलब एक stone है, we are rotating that stone in a vertical circle, right? So you have to tell me at what point the tension will be maximum. देखो इतना easy question है, so easy question. और इस type of question we have already, if you have attempted, हमने already सब क्वेश्चन सॉल्व कर रखे हैं, है ना. Yes, one second, क्या हो गया. हाँ ठीक है. ऑप्शन ए, बी, सी और डी. क्विकली, वी आर हैविंग अ स्टोन. एक स्टोन है, इसको हम रोटेट कर रहे हैं, राइट, इन अ सर्कुलर पाथ, इन अ वर्टिकल सर्कुलर, और एट कांस्टेंट ओमेगा. ओमेगा इज कांस्टेंट. लेट्स से दिस इज ओमेगा. ओमेगा इज कांस्टेंट. So at what point the tension in the string will be maximum? Okay, Mani is going with option D. Vicky, what is the option that you can A, B, C or D? At the top of the circle, half way down the top, or quarter down the top or bottom of the circle, at which point the tension in the string will be maximum? Obviously, without any doubt, option D is a correct answer, है ना. ऑप्शन डी इज करेक्ट, बिकॉज इफ यू ट्राई टू विजुअलाइज, अगर मैं इसका फ्री बॉडी डायग्राम बनाऊं, लेट्स से दिस इज द स्ट्रिंग, राइट, दिस इज द टेंशन टी, this is your mg, and the body is having a radial acceleration that is your ar. So we can say t minus mg is equal to m into ar, or t is equal to mg plus m into ar is m r ओमेगा स्क्वायर, है ना, r ओमेगा स्क्वायर. एक सेकेंड यार, ये क्या हो गया. ठीक है, r omega square, right? So at the bottommost point the tension in the string will be maximum. Option D is a correct answer. Clear? Acha, tell me, this is done. What is the minimum velocity to complete the circle? What should be the minimum velocity? किस minimum velocity से it should be rotating so that it can complete the circle? Anyone who can tell me? इस टाइप के क्वेश्चंस we have already discussed, है ना. What is the minimum velocity with which this body should be rotating in order to have a complete circular motion? So minimum velocity at to complete the circle, can you tell me? Answer is an option D is the correct answer. Okay, but let us try to have a further understanding. What is the velocity with which this body should be rotating so that the body will be able to make a complete circle? What is the velocity over here? Kiss velocity it should be moving so that the body is having this one. Chaliye. Yes, याद आ रहा है कुछ? रूट जी आर या रूट 6 जी आर या रूट 3 जी आर, something like this. These are some set of results that you have to remember. What is the minimum velocity at the bottommost point, so that the body is able to make a complete circular motion? Anyone? विकी, मनी, अरे यार ये सब बहुत ही टिप्स में होने चाहिए. अच्छा, टॉप मोस्ट पॉइंट है, व्हाट इज द मिनिमम वेलोसिटी विद व्हिच यू शुड बी रोटेटिंग? रूट जी आर है ना. एट द बॉटम मोस्ट पॉइंट व्हाट इज द वेलोसिटी शुड बी रोटेटिंग? रूट 3 GR, दैट्स इट, है ना. रूट 3 GR. Okay, and you can place it over here because this is also equal to mg plus mv square by r. You can click on this and you can place over here and you can get the final answer. ठीक है. The minimum tension in the string will be equal to, you can place it, the minimum velocity, वहां से आपका यहाँ पर clearly हो जाएगा. Right? Okay, done. चलिए next question. ये बहुत ही इजी क्वेश्चन था. दिस वाज आस्क्ड इन 92 और 93. A shell is fired from a cannon with a velocity v at an angle of theta with the horizontal direction. At the highest point in its path, it explodes into two pieces of equal masses. One of the piece retraces its path to the cannon. The speed of the other piece immediately after the explosion is. Yes, let us see. We are having a shell which is being fired at an angle of theta with the horizontal. Okay, right, and it is making a projectile motion. Definitely it will be making a projectile motion. Now at the topmost position it is exploding into two halves, right, and one of the piece is retraces back to its own part, to its own, we can say, cannon. What is the speed of other piece immediately after the explosion? Option D. Okay, anyone else? देखो simple है, because in the horizontal direction there is no acceleration, air resistance always being neglected, so there is no force being applied, so we can apply the conservation of linear momentum. You apply the conservation of linear momentum at the initial and the final point. You can apply over here and you can apply over here. Quickly apply the conservation of linear momentum and tell me what is the speed of the other piece immediately after the explosion. Is it 3v cos theta, 2v cos theta, 3/2v cos theta, or root 3/2v cos theta? A simple question. देखो horizontal direction में this velocity is responsible v cos theta, है ना? And because in the horizontal direction there is no acceleration, there is no force being applied, the body is moving with the constant velocity in the horizontal direction. So can we say, applying the conservation of linear momentum, applying the conservation of linear momentum, initial is m into v cos theta. This is the initial momentum. After explosion, both mass is dividing into half of, or we can say equal pieces, two equal pieces, right? Two equal masses. So we can say this is equal to m/2 into v cos theta with a negative sign. Why negative sign? Because one of the mass is retraces its path to the cannon, so it will be moving in an opposite direction. Let's say it is having a v dash velocity, so this is plus m/2 v dash value. Okay, so from here we can say this is equal to 3 mv/2 cos theta is equal to m/2 v dash, right? So v dash is equal to 3v cos theta. So after the explosion, the second part will be having a velocity of 3v cos theta. Option A is the correct answer. और obvious बात है ना, क्योंकि देखो horizontal direction में the body is moving with constant velocity at each and every point. The velocity will be v cos theta, है ना? Fine. At the topmost point also it will be having v cos theta before explosion. Okay, before explosion. Clear? Yes. All right, done. 3v cos theta. v square क्यों नहीं होगा? v square कहां से होगा? Mass into velocity, momentum, conservation of momentum, initial momentum and final momentum. This is before collision. This is बिफोर कोलिशन और यहां पर है आपका आफ्टर कोलिशन और आफ्टर एक्सप्लोशन. This is before, instead of collision we can write it as explosion. This is before explosion and that is after explosion. V square कहां से आएगा, है ना? Momentum, mass into velocity. And why we can apply the conservation linear momentum? Because the force is equal to 0. That's it. Chalo, next question on the screen. Okay, a block of mass 5 kg is thrust up a 30-degree inclined plane with the initial velocity of 4 meter per second. It travels a distance of 1 meter before it comes to rest. What is the force of friction acting on it? A very easy question. There is a body which is moving up in the up direction, right, with some initial force being applied. Okay, fine, it is moving in the upward direction. Fine, and if I try to resolve the force, we'll be having mg cos theta. Let's say this angle is theta, right, and this is mg sin theta, and the friction will be in this direction. This is the direction of friction, right? So they're asking you what is the direction of friction force. Very easy problem. आपको यहाँ पे initial velocity it is being given as 4 meter per second. Initial velocity is equal to 4 meter per second. Your distance traveled is equal to 1 meter. It is moving from this point to this point. So what will be the frictional force acting on the body? First of all, calculate the acceleration. First of all, calculate the value of acceleration, and then we'll be able to calculate the value of friction force. Quickly. Quick. And because initial push के बाद we are releasing the force, so we'll be having a retardation. क्योंकि initial velocity is 4 meter per second, and after some point of time the body is coming to rest, so we'll be having a retardation over here. So first of all, calculate the value of acceleration. Acceleration कैसे निकालेंगे? Can we use we can say v square is equal to u square plus 2 into a into s. From there get the value of acceleration. Once a is being calculated, use your equilibrium condition and get the value of the friction force. So we can say v square is equal to u square plus 2 into a into s. Because this is a retardation case, final velocity is equal to 0, initial velocity is 4 square plus 2 into a into ss1. So a is equal to minus 8 meter per second square. Minus simply indicates that it's a retardation case. Negative का मतलब है it's a retardation case, right? Fine. Now, now we can apply. We can say mg sin theta plus f is equal to mass into acceleration, where a is retardation, so that is the reason we can take it as negative sign over here. So mg sin theta plus f is equal to m into ms. A is how much? A is 8. Okay, so f is equal to m is 5. 5 into 8 minus 5 into 10 into sine of 30 degree. So what is the value you are getting? 40 minus 25, 15 Newton. Hai? Yes, are we getting 15 Newton? Array 40 minus this is equal to 25. 25 हो जाएगा 50, 25, 15, हाँ 15 Newton is the final correct answer. Clear? So the friction force that will be applied on the body, this amount of frictional force will be applied. This is the frictional force that will be applied. Okay, that is the 15 Newton will be the final correct answer. 15 Newton. Done. 15 Newton will be the final correct answer to this problem. Okay. Done. Any doubt, any problem, please tell me. All clear? The questions, I'm again repeating, questions का level was not at all difficult. उस time पे questions का जो level था, that was very basic, है ना? And now questions level, अब जैसे recent year देखेंगे, almost इसी का ही थोड़ा modified version है. Fine, जो इससे भी easy question थे, I have not taken that because there is no point of taking much more easy than this. Okay, next question on the screen. Achha, before going to the next question, this Sunday we will be having a scholarship test for the GATE examination for all the students, those who are planning to give GATE in 2025. So it's a golden opportunity to avail the scholarship so that you can the preparation should not be hampered, and you'll be able to get up to 90% off on the programs. Okay, so next on our app, just I promise at 12 p.m. from Saturday, from tomorrow Saturday, we'll be having 12 p.m. onwards. Only for today we'll be having 4 p.m. as the app class, right? Only for today, but from Saturday onwards we'll be having 12 p.m. 12 to 1 every day except Sundays. We'll be having the classes, the practice sessions of the different subjects, your for HPCL, for ESE, for GATE examination, all examination keeping in mind, will be having the different practice set for the different subjects. Okay, chalo, next question on the screen. A ball A of mass m falls under gravity from a height h and strikes another ball of mass m, which is supported at rest on a spring of stiffness k. Assuming perfect elastic impact, immediately after the impact, which of the following statement is correct? That means just after the impact, which of the following option is correct? Chaliye, velocity of ball A is equal to 1 by 2 root 2 gh, velocity of ball A is equal to 0, velocity of both balls is equal to 1 by 2 root 2 gh, or none of the above. Which of the following is correct answer? देखो पहले डायग्राम बनाइए. देखो whenever you are having question from mechanics, डायग्राम तो बनाना मैंडेटरी है if you are getting questions like this, है ना? Then you can analyze and you can proceed with the solution. Okay, so there is a ball A which is falling under gravity from height h and is striking a ball B which is resting on a spring, which is resting on a spring, right? So the question is, just after the impact, what are the velocities of both the balls that we have to calculate? So tell me, what is the initial velocity of ball A just before collision? What is the initial velocity of ball A just before collision? Anyone? Quickly. The initial velocity of ball A will be equal to root 2gh. Yes, will be equal to root 2gh. And because ball B, which was stationary, which was supported at rest, so we can say u B is equal to 0. And both are having the same mass, I think, both are having the same mass. It is perfectly elastic impact. Perfectly elastic impact. Let us suppose after collision, the velocities are VA and VB respectively. If you remember one statement in our paid class, I have already told you, whenever two masses having, if two bodies having equal masses are undergoing perfect elastic collision, then their velocities always exchange with each other. That means the initial velocity of ball A will be exactly equal to the final velocity of ball B, and the initial velocity of ball B will be equal to final velocity of ball A. We can prove this also, right? Option C, dekhte hain. So we can say, if you're applying the conservation of momentum, if you apply the conservation of linear momentum, we can say MAUA plus MBUB is equal to MAVA plus MBVB, right? This is equal to 0 because the body B is initially at rest. This is at rest at the initial condition. So we can say, and mass get cancelled out because both are having the same masses. So UA is equal to VA plus VB. Let's say this is equation number 1. And because the body is having perfectly elastic impact, so we can say the coefficient of restitution will be equal to 1 for perfectly elastic collision, perfectly elastic impact. So E is equal to VB minus VA divided by UA minus UB. So from here we can say UA is equal to VB minus VA. Let's say this is equation number 2. Adding equation 1 and 2, we can say UA will be exactly equal to VB. UA will be equal, because VA and VA get cancelled out. 2 UA is equal to 2 VB. So this is equal to root 2GH. And if UA is equal to VB, place it over here, we'll be getting VA is equal to 0. And that is the same thing. Because body A ka initial velocity was equal to root 2GH. and body B ka initial velocity was equal to 0. After collision, body A velocity is equal to 0 and body B velocity is equal to root 2gh. That means whenever two bodies having equal mass, when they are having a perfectly elastic collision, then their velocities exchange with each other. That was we already discussed. So over here we can say option B is the correct answer. The velocity of ball A will be equal to 0 in this particular question. Done. Is this clear? Can we proceed now? B, हाँ, perfect. B is the correct answer. बहुत बढ़िया. चलो, next question. Okay, a very easy question from the rolling. A wheel of mass m and radius r is in accelerated rolling motion without slip under steady axial torque T. So there is a roller or is a wheel which is basically rolling due to an applied torque T, and a torque is being applied. And if the coefficient of the kind of friction is mu, then what is the frictional force from the ground on the wheels? Very easy question. What is the, and because this is a rolling motion, we can say A is equal to R into alpha. Chaliye, quickly. What will be the frictional force from the ground on the wheels? What will be? Now tell me, what's the direction of friction force? Towards left or towards right? What is the direction of frictional force? Towards left or towards right? Definitely it will be towards right, because the torque apply kar raha hai. Torque is trying to rotate this body in the clockwise direction. So at this point, there will be a friction force acting on the right hand side. Okay. So we can say your torque is trying to rotate clockwise, minus F into R is equal to I into, let's say I'm talking about point IO into alpha. Yes, right? So what is the mass moment of inertia of a wheel? This is a rigid wheel. We can say mr square by 2. So T minus F into R is equal to mr square by 2 into alpha. Right? Fine. Is this clear? Chalo, now let us try to apply the force equation. There is only one force, so F is equal to mass into acceleration. So F is equal to m into r into alpha. Placing this equation over here, we can get this T minus D minus F into R is equal to mr square by 2 into alpha. So from here, alpha is equal to mr square by 2 into alpha s. We can say alpha, we can write it over here as this one, right? So we can say alpha is equal to F by mr, right? So from here we can get the value of the relation between this and this, mr. So this is T is equal to Fr plus Fr by 2, that is 3Fr by 2 is the tension value, and this we can say F is equal to 2 by 3 T by R. This is the frictional force, 2 by 3. So option D is the final correct answer. Option D is the final correct answer. Is this clear? Option D is the final correct answer to this problem. Understood? Option D, because the tension is coming out to be the, we can say the torque will be equal to 2 by 3rd of the torque by R is equal to the frictional force. That is basically is coming in this particular equation. Clear? Chali, next question. Now this kind of question is being repeatedly asked nowadays also. This was asked in 1998, and if you remember, the same question was asked in the recent year, the gate problem. Agar aapko yaad hoga, this is a ladder problem, and you can easily now apply with the concept of instantaneous center method. Apply and tell me what is the answer. A rod of length 1 meter is sliding at one of the corner as shown in the figure. At the instant, the rod is making an angle of 60 degrees with the horizontal plane. If the velocity at point A is 1 meter per second, then what is the angular velocity of the rod? Very easy question. Yes. ऐसे क्वेश्चन तो आज के डेट में भी recent if I say gate examination, they are asking these type of questions, right? So quickly, what is the answer? What is the angular velocity of this rod? इस type of questions we have solved n number of times in our sessions, different sessions, right? देखो, we are having a rod, this one, this is point A, this is point B, this is VA, right? So this eye center will definitely be located somewhere around here. This is your eye center, okay? And say this is VB, this angle is 60 degree, right? And AB length is, this is point B, AB length is 1 meter. 1 meter is the length of the rod. Quickly, what's the answer? Is it 2 radian per second, 1.5 or 0.5 or 0.75? We can say VA is equal to AI into omega. VA is given as 1 meter per second. What is the distance AI? This is 1 meter. This is 1 cos 60. 1 cos 60 into omega. So cos 60 is 1 by 2. Omega is equal to 2 radian per second. Option A is the correct answer. Option A is the final correct answer. ठीक है, इस टाइप के क्वेश्चन तो हमने इतनी बार किए हैं, आई थिंक मेनी नंबर ऑफ टाइम. इससे बहुत डिफिकल्ट क्वेश्चन वी हैव सॉल्व्ड इन आवर सेशंस, राइट? एंड लेट 90s में दिस टाइप ऑफ क्वेश्चन वाज आस्क्ड. आज भी इस टाइप क्वेश्चन इज बीइंग सीन इन आवर डिफरेंट PSU एग्जामिनेशंस आल्सो, राइट? 2 रेडियन पर सेकंड, वेरी गुड. अच्छा, कैन यू टेल मी व्हाट विल बी द वेलोसिटी ऑफ पॉइंट बी? आउट ऑफ क्यूरियोसिटी, कैन यू टेल मी व्हाट विल बी द वेलोसिटी एट पॉइंट बी? What will be the velocity at point B? क्या होगा? Simple है sir. We can say VB is equal to BI into omega. If I want to calculate the velocity at point B, that is equal to BI into omega. BI is equal to 1 sin 60. 1 sin 60 into omega is 2. So sin 60 root 3 by 2. So root 3 मीटर पर सेकेंड. velocity at point B, रूट 3 मीटर पर सेकेंड, है ना? रूट 3, रूट 2 कैसे आएगा भाई? व्हाट विल बी दिस डिस्टेंस? दिस इज इक्वल टू 1 sin 60, है ना? sin 60 is root 3 by 2. 2 and 2 get cancelled, so root 3 meter per second is the velocity at point B. Perfect, very good. बहुत बढ़िया. Next question. विदाउट ट्रस्ट प्रॉब्लम एंड विदाउट रिएक्शन फोर्स कैलकुलेशन आपके मैकेनिक्स के प्रॉब्लम्स कंप्लीट नहीं होते. सो वन क्वेश्चन फ्रॉम दिस योर रिएक्शन फोर्स कैलकुलेशन. A mass of 35 kg is suspended from a weightless bar AC which is supported by a cable CB. Okay, this is your cable CB, right? And we are having a pin jointed at point A. What is the reaction at point A? What is the reactions at point A? The horizontal and vertical reaction. बहुत easy question है. Try to apply a logic and tell me the final correct answer. बहुत easy question है. Well, let us suppose we are having the reaction force over here. Let's say this is Rx and this is Ry, है ना? Now, चलिए, let's see who's gonna give me the answer. We are having Rx and Ry, है ना? Quickly. डिजिट क्लियर नहीं हो रहा. ओके, 275 डायमेंशंस. अच्छा, मैं अब एक काम करता हूँ, यहाँ पर बना देता हूँ. देखो, ये रॉड है, दिस इज द रॉड. वी आर हैविंग मास कितना है? 35 kg. देयर इज अ टेंशन T. आई एम ड्राइंग द फ्री बॉडी डायग्राम डायरेक्टली. T and this is theta. This is something like this, is having a height of 125 mm. And this is having a width of 275 mm. Okay, clear? थोड़ा इसका एंगल को ठीक कर देता है. राइट, अब हो जाएगा. चलिए, let's say this is Rx, this is Ry. This is Rx and this is Ry. Quickly, what is the value of Rx and Ry? This is the question they're asking. This is point A, this is point B, and this is point C. Quickly, what is the horizontal and vertical reactions that you will be getting by solving this problem? इससे easy question नहीं हो सकता. जल्दी बताइए आंसर. You take moment about point A, that's it. Now you take moment about point A and make it equal to 0. So I can say t sine theta into 275 is equal to 35g into 275. तो यहां से we can say t sin theta is equal to 35g. Perfect, है ना? मतलब t is equal to 35g by sin theta. So if I take will be equal to t cos theta, right? So t is nothing but 35g by sin theta. So 35g by sin theta into cos theta. So this is 35g by tan theta. What is tan theta? Over here, if you see, tan theta is equal to 125 by 275. Place it over here and tell me what is the value of the reaction force that you are getting. Quickly, कितना आ रहा reaction force? 35g by tan theta. कितना आ रहा है? Solve कीजिए. You'll be getting 35. Take it as 9.81. 9.81 into 275 divided by 125. 755.37 in Newton. Are we getting this one? Please check. 755.37 is the horizontal reaction. So we are not getting this. ये भी नहीं हो सकता. तो C और D में से एक होगा option. C और D में से होगा. अच्छा, what will be the value of vertical reaction? The total vertical force equal to 0. Ry in the upward direction. Ry in the upward direction. Minus 35g in the downward direction. And T sin theta in the upward direction. And we already know that T sin is equal to 35g. This get cancelled out. So Ry is equal to 0. Ry equal to 0. So यहाँ पे option D is the correct answer. Very good, Mani. Very good. Ry is equal to 0. So option D is the final correct answer. Option D is the final correct answer. Clear? Done? Okay. Simple question. Question देखो, mechanics is a very, again I'm repeating, mechanics एक scoring subject है. And try to secure at least, अगर मान लीजिए 3 या 4 क्वेश्चन पूछता है, ये मान लीजिए 2 क्वेश्चन भी पूछता है, you should be able to attempt all the question appropriately. ठीक है, चलो next question. Okay, this was a question asked in GATE 1999, I think. As shown in figure, a person A standing at the center of the rotating platform facing B, who is riding a bicycle heading east. The relevant speed of the distance are shown in the diagram. A bicycle heading east heading east. At this instant, what is the apparent velocity of B with respect to A? What is the velocity of B with respect to A? This is the question they are asking you. What is the velocity of point B with respect to A? Achha, tell me, a body who is standing at the center of the rotating platform, what is the velocity, linear velocity at point A? एक बॉडी है जो एक रोटेटिंग प्लेटफॉर्म के सेंटर में खड़ा है, तो उसमें तो कोई लीनियर वेलोसिटी होगा नहीं, क्योंकि रेडियस इज इक्वल टू 0. कैन वी से वी इज टेंडिंग टू इक्वल टू 0, क्योंकि वो सेंटर में खड़ा है. सो वी कैन से वेलोसिटी ऑफ बी विद रिस्पेक्ट टू ए विल बी इक्वल टू वीबी माइनस वीए, दैट इज इक्वल टू 8 माइनस 0, दैट इज 8 मीटर पर सेकेंड, एंड इट विल बी हैविंग द सेम डायरेक्शन, दैट इज टुवर्ड्स ईस्ट. ईस्ट डायरेक्शन में मूव करेगा. ऑप्शन सी इज द करेक्ट आंसर. And this was a PYQ question, गेट का क्वेश्चन था ये. बहुत इजी था, आई थिंक. एप्टीट्यूड, हाँ एप्टीट्यूड क्वेश्चन जैसे लग रहा था. ओके, डन. चलो, लेट्स ट्राई टू सी सम मोर इंटरेस्टिंग क्वेश्चन फ्रॉम योर ओल्ड PYQs. What is the moment of inertia of a square of size 1 unit about its diagonal? बहुत इजी क्वेश्चन है. So there is a square. They're asking you what is the moment of inertia of the square about its diagonal. Let's say this is A, B, C or D. आपको बताना है AC के about what is the moment of inertia. Is it 1/3, 1/4, 1/12 or 1/6? अगर आपको याद है रिजल्ट्स, यू कैन डायरेक्टली अप्लाई. अगर याद नहीं है when then we can go for a simple calculation, and each is having a side of 1 unit. Each is having a side of 1 unit. देखो, whenever you are getting these type of questions, if you remember the results, perfect. If you don't remember the result, then we have to apply simple logic. Acha, tell me, if you're having a triangle having base B and height H, what is the moment of inertia about its base? If you're having a triangle with base B sorry, and height H, then what is the moment of inertia about the your base? अगर मैं यहाँ पे एक ट्राइंगल लूँ, सिंपल, आई एम टेकिंग अ ट्राइंगल, दिस इज बेस B and this is height H. So about this base, that is equal to BH cube by 12, है ना, BH cube by 12. Let us take over here, यहाँ पे जो स्क्वायर का बेस कितना होगा, that is equal to 1, this is 1, this is equal to root 2. हाइट कितना होगा, this is root 2 by 2, so this is root 2 by 2 or 1 upon root 2. Height hoga 1 upon root 2. So we can say the moment of inertia about base is equal to BH cube by 12. This is root 2 into 1 upon root 2 whole cube by 12. So this is equal to 1 upon 2 into 12. This is for half the triangle. अगर मुझे बाकी रेस्ट पार्ट का भी लेना है, so the moment of inertia about the diagonal will be equal to 2 times of 1 by 2 into 12, that is equal to 1 by 12. Okay, so answer is option C. ये आप remember रख सकते हैं, you can remember like this. If you're having a square having a let us suppose each having a side of A, then A by 12 will be the moment of inertia about its diagonal. ठीक है, 1/12 will be the moment of inertia, or we can say A by 12 will be the moment of inertia of the square about its diagonal. Clear? ये कुछ results है, you can do remember. If not, you can do proceed like this. चलो, next question. From truss, for the loading on truss shown in the figure, the force in the member CD. वेरी इजी क्वेश्चन. ट्रसेस के बिना तो हमारा जो डिस्कशन है वो अधूरा ही रहता है ना. व्हाट इज द फोर्स इन द मेंबर CD? Again, apply the method of section. Apply method of section. Apply method of section and tell me the answer. It is a very easy question. Now, because this is an symmetrical body, each will be having the same reaction, that is 1 kilonewton and 1 kilonewton, right? Let us take a section from the center, remove the left or right, either way it's all correct. If we take the right hand sides, we'll be having a diagram like this. Okay, this is FCD, this is your 1 kilonewton, this is, oh sorry, downward. This is 1 kilonewton, this is 1 kilonewton, right? So let's say this angle is theta. So we can say FCD sine theta in the upward direction plus 1 minus 1 equal to 0. So FCD is directly equal to 0. That is a zero force member. Option A is the correct answer. That is a zero force member, है ना? Right? The force in the member CD is equal to 0. Done. चलिए, next question. हाँ, easy, very easy, interesting. There are two bodies, 1 and 2, as shown in the figure. Both are having the same mass. All the surfaces are smooth. The value of force P required to prevent the sliding of body 2 on body number 1. What will be? And all are smooth surface. There is no friction. So how much amount of force do I need to apply on the body so that on body number 1, so that body number 2 is kept on rest condition? Root 2 mg. Pakka, sure? Free body diagram banao. Draw the FBD. Let us draw the FBD of this body number 2. If I try to draw the free body diagram of body number 2, ये आपका body number 2 है. This is your mg cos theta. This is your mg sin theta. And this is your normal reaction, है ना? अब technically there is a smooth surface, so mg sin theta needs to be nullified. अगर mg sin theta को मैंने nullify कर दिया, इसको मैंने कुछ ऐसा force लगाया that it is equal to 0, then problem is solved. Then the problem is solved, है ना. अब क्योंकि यहाँ से एक force लग रहा है P, right? So we can say same amount of force will be pulled by the same this one P. This angle is theta. Let's say this angle is theta. This angle is also theta. So we can say P cos theta will be responsible to remove this mg's, because देखो इस body को नीचे गिराने वाला component is mg sin theta. इस body को नीचे गिराने वाला component is mg. So that particular force need to be nullified. So I can say mg sin theta must be exactly equal to P cos theta. Theta being 45, we can say P is equal to mg. Option D. P is equal to mg. That's it. क्योंकि mg sin theta is the only force responsible for body to slide downward. So I have to say that I need to apply a force which will be able to nullify that. अब मैं इस body को force P से इस तरफ मैं धक्का लगा रहा हूँ. So definitely इस body पे एक force लगेगा P in this direction. To every action there is equal and opposite reaction. इसी force P लगेगा. Right, now this is P, then definitely if I try to resolve this force, this is P cos theta. So P cos theta will be responsible for restricting this body for the downward motion. So cos theta and sin theta will be cancelled out because theta equal to 45. So from here P is equal to mg. We are getting the final answer. Simple. Clear hai? Done? Understood? Next question. चलिए अब एक क्वेश्चन है, लास्ट क्वेश्चन है फ्रॉम द बेल्ट ड्राइव, बिकॉज दैट उस टाइम पे देयर वाज नॉट इन द सिलेबस दैट जैक स्क्रू जैक और योर दिस वन वेज फ्रिक्शन, रोलिंग फ्रिक्शन, ये सब के क्वेश्चंस पहले एप्लीकेशन ऑफ फ्रिक्शन एप्लीकेशन वाज नॉट देयर, बट बेल्ट फ्रिक्शन वाज देयर. सो आई हैव टेकन दैट प्रॉब्लम. 90s का एक प्रॉब्लम है. लेट अस ट्राई टू सॉल्व इट. In a band brake, the ratio of tight side band to the tension of the slack slide is 3. That means the tension of the tight side to the tension of the slack slide is equal to 3. The angle of overlap of the band of the drum is equal to 180 degree. What is the coefficient of friction required between the drum and the band? What is the coefficient of friction required between the drum and the band? Very easy problem. For belt friction, if you remember, there is only one expression in the belt drive, that is equal to T1 by T2 is equal to e to the power mu into theta. If you remember, tension on the tight side to the tension on the slack slide is equal to e to the power mu into theta. Okay, so यहाँ पे T1 and by T2 is being given, theta is given, you can get the value of mu. चलिए, what is the answer? And make sure you are converting this into radian. Degree में मत रखिए, you will be getting wrong answer, right? So theta is equal to pi radian, right? So placing over here, 3 is equal to e to the power mu into pi. So mu is equal to how much? Ln of 3 divided by pi. We are getting 0.3497. 0.3497 is the coefficient of friction between the belt and the pulley. So from here we are getting 0.345. Option D is the correct answer. Option D is the final correct answer. Is this clear? Understood? Okay. So variety of questions the, but some questions were so basic, so that we were I'm not taking that. 0.3974 एक बार check कीजिए. प्लीज मेक श्योर कन्वर्टिंग दिस इनटू रेडियन. 180 मत यूज कीजिए, 180 यूज करेंगे आंसर गलत आएगा. इफ यू आर यूजिंग 180 यू विल बी गेटिंग अ रॉन्ग आंसर. ओके, यू हैव टू कन्वर्ट द यूनिट इनटू एसआई यूनिट, दैट इज रेडियन. सो प्लेसिंग ओवर हियर लॉगरिथमिक मत लीजिए, एन लेना है, log to the base e, log to the base e, right? So we are getting 0.3497 as the final correct answer. So option D is the correct answer for this problem. Okay, fine. So this was some set of questions that I wanted you to revise for your GATE or even for the different PSU examinations. And if I talk about GATE 2024 course, there is a crash course already being launched, and already like 50% of the syllabus is already being over, and we are almost on the verge of completing this crash course. Those who are not yet, or those who want to revise the subjects, for in a very short span of time, definitely you can go for this crash course. And those who are planning for 25-26, the GATE ESC batch is already being launched. Okay, so thank you guys for joining with me. I'll be sharing this PDF on my Telegram channel. You download from there, and if you have any doubt or difficulty, do let me know in any problem if you have. Okay, fine. So thank you guys. Bye bye. Take care, and we'll be meeting tomorrow. Tomorrow we'll be meeting. If I say an app, we'll be meeting today at 4 p.m. in our app classes. App class, right? And today the topic is from theory of machine. This is for today. Okay, and tomorrow we will be meeting at 12 p.m. on our app classes. App class, the link will be shared at around 11:30, and at 5 p.m. we'll be having the HPCL practice. Okay, industrial engineering. The subject will be in it, and this will be on YouTube. Okay, this is the schedule for today and tomorrow. So do follow me, and if you have any doubt or difficulty, you can do connect me on my Telegram channel also, right? Okay, so thank you guys. Bye bye. Take care. Stay safe and enjoy your festive season. But make sure you are at least sparing 2 to 3 hours on daily basis on your studies, because the momentum should not be completely break. It should be slowed during festive, but after that, after Sunday, you need to accelerate and you need to practice a lot many questions. Okay, so thank you guys. Bye bye. Take care. Stay safe and enjoy your day with BYJU'S exam prep. Thank you.